Right. So, just a side note of what we talked about on the quiz. On the quiz, and pay attention because you're going to be typing into your calculator right now, you're in radians. If I wanted to test tangent of 10 and cotangent of 90, we're going to talk for, now I know I'm in degrees and you're in radians, so don't even push anything in your calculator till I tell you to. Right now, it would be pointless to push this into your calculator, all right? Because you're in radians, right? I'm just talking. You're not pushing. You're just listening, okay? These are equal to, I'm sorry, that wouldn't even be true. This should be 80, okay? These two things will equal each other because they're co-functions. We don't use the co-function identities very often, so I need to go over them a lot with my students or periodically. They are complementary, okay? Co-functions are complementary. So everybody knows how to push tangent 10 degrees into their calculator. In degree mode, you would get some decimal value. To put in cotangent, you just say 1 over tangent of 80. Does that make sense? You should get the same answer either way. Obviously, it's easy to check sine of 20 and cosine of 70. Right now you're in radians, so it won't work. But my point is that should work, okay? What if on a test I asked you sine of 120 equals cosine of blank? The fastest way to do that is make them complementary because they're sine and cosine, they're co-functions, okay? And so I would call this negative 30 degrees. What do those add up to? 120 and negative 30. They add up to 90. That will work if we were in degrees. If I have secant of 2 degrees, that will equal the cosecant of 88 degrees. This I would not type in as inverse cosine. That is not what this is. This is the reciprocal of cosine. Do y'all see what I mean? Okay, and this is the reciprocal of sine, and we should get the same values. That's what cofunctions are about. Now if we're in radians, it's a little harder to see. 90 is really easy to see, okay? If I have the cosine of pi over 7, that should equal the sine of whatever pi over 2 minus pi over 7 is, which we could do in decimals or exact, okay? I'm just going to go ahead and do it this way with the pi in it, or you could give me decimals. I'm going to change the common denominator to 14. So if I multiply this by 7 and this by 2, that gives me 5 pi over 14. Are y'all with me? Okay. So now that you're in radians, please type this in and see what you get. Hit enter. And then type this in and hit enter. 5 pi over 14, thank you. Katie, so much. She's my corrector, okay? Apparently I need one really bad after the last few days because I made lots of mistakes.
Pi over 2 or 7. Pi over 7 is the first one.
Pi over 7. Cosine of pi over 7 and sine of 5 pi over 14. Did it work?
Yeah.
You get the same exact answer. All right, hang on just a minute. Let me take some questions. Nicole?
This may be like a dumb question, but why is it that it's for like tan and cotangent, its cofunction is the inverse of it, but cosine and cosine, its cofunction isn't the inverse?
Tangent and cotangent have this really weird relationship. I don't know if you've ever heard of double first cousins. You know, like if like brothers marry sisters, that's fine. Like say you and your, I don't know if you have a sister, but if siblings marry siblings, then you have your first cousins. That's called double first cousins.
Yes.
Okay. Whereas I just have first cousins. Tangent and cotangent are double first cousins. They happen to be reciprocals of each other and co-functions of each other.
Okay.
But when they were named, what they were named in the English language, they already knew the co-function thing, so they named them sine and cosine, tangent and cotangent, secant and cosecant. And then they started finding out the reciprocal.
So the
And then we're like, whoa, these even have more.
Okay.
All right, girls, listen. Great question. Lindsay?
So for the one that's sine of 120, so could you also find like the reference angle, do like sine?
Well, my point, if you're using co-functions, is just subtract it from 90. 90 minus 120 is negative 30. So I would be asking you a co-function identity question blatantly because I'm asking sine and cosine. There's many things you could put in that blank that would probably equal sine of 120. But my point of the question is the co-functions. Okay? All right, now why don't you do one? Let's do tangent of 2 pi over 3 equals the, sorry, that red's kind of aggravating. Tangent of 2 pi over 3. Find out what it is equal to. And like Lindsay and I were talking about, the instructions here would be use co-functions to fill in the blank, which would be the easiest way to fill in the blank. Now, if you were in degrees, this is why I started at the top. What was I saying? Wasn't I saying 90 minus 20 to get 70?
Is it 2 pi over 3 or
2 pi over 3, that's a 2 pi over 3. So if you're in degrees, subtract this angle from 90. If you're in radians, what are you going to subtract it from? Pi over 2. And I wouldn't round it off if you're using decimals. Do y'all all know how to say answer? Second answer? And we'll just pull in the last thing you have.
And divide by pi. Like, I mean, it's not like the fraction. Never mind.
If you go pi over 2 minus 2 pi over 3 in your calculator, the pi's already embedded in there.
Yeah, so then like,
You don't need another pi.
no, I was just wanting to like, it's like if you divide like whatever answer you get by pi, then you get like the root, right?
Oh, yeah.
without a negative?
You mean to go back to the exact answer?
Yeah, but if it's negative, then you go in degrees, what would it the last time you
Did you get negative pi over 6?
Yeah.
Anybody else get negative pi over 6? All right, and now let's type it in. You're in radians. Put in tangent of 2 pi over 3. We should get negative 1.732.
Yeah.
Okay? And now go, how are you going to type in cotangent? You have to say 1 over tangent, because they're reciprocals, of negative pi over 6. Do you get negative 1.732?
Yes.
Okay. All right. So co-functions, to wrap that up, they could now land on your memo page, but you wouldn't have to work it out. Memo page is about quickness. If I say secant of 90 minus theta, that would equal the cosecant of theta. Does that make sense?
Yes.
Okay, because these have to add up to 90 degrees. All right, if I say pi over 2 minus theta, it's still the same thing. I'm just in radians. All right, so now remember your calculators are in radians. By the way, some people have walked out of like an ACT or another test and panicked. It's like, oh gosh, my calculator was in radians or degrees or whatever. The only time it matters what mode your calculator is in, the only time is if you're going to push sine, cosine, or tangent. Okay? Like if you have 4 plus 8 radians, you've got 12 radians. Do y'all see addition, subtraction, square rooting? The only time it's affected if you push sine, it needs to know if you're at 1 degree or 1 radian. Okay? So don't super panic unless you push sine, cosine, and tangent a lot. Then you might have been in the wrong mode. Every time your little finger goes to push sine, cosine, and tangent, before you push it, I wish a buzzer went off and went bzzz, okay? You should think about what mode you're in before you push those buttons in math and science, all right? Okay, now let's go to number 2 on the worksheet. Number 2, I was trying to get you used to what was going on with S equals R theta. All right, so you have a wheel of radius 9 inches. That's revolving at a high RPM, 2,400 revolutions per minute. That's what RPM means. I don't know if you've ever popped open your DVD player before, like it had stopped spinning, and it goes really fast. It's whirring really fast, okay? If you've ever, it's so funny that I say these words because I came from an environment where some people had 3 cars, okay? We all had a 3-car garage, and now I don't have a car. So I don't know how much you're at in a car, or look at the dashboard of a car. A lot of times if you're in a car, you're in the back of a taxi, and you can't see the dashboard. But those of you that actually are driving a car, and you see the dashboard, which I used to be able to ask my whole class, like, what do you see? You have a couple of displays up there. One of them is how fast you're going. The other one is RPMs. Has anybody ever noticed that? Yeah. And if you notice it, it'll go 1, 2, 3, 4. Does anybody know what it says times? Yes. So let's pull one up because most, pre-New York days, people would know what that meant.
She lived in Florida.
Hey girls, do you see us talking about something in your car that's going like 6,000 revolutions per minute? They didn't even bother with anything less than the thousands. 1,000, 2,000, 3,000, 4,000, okay? So next time you're in a taxi, maybe you can like look for this display and it's all up there for you to see, all right? So this is not out of the realm of possibility. So back to this. This wheel is going 2,400 revolutions per minute. Find the angular speed of the wheel. I do not need a formula for angular speed, okay? Angular speed is just theta. It's going 2,400 revolutions per minute. If I really want the angular speed, listen to the words. You're just telling me how fast it's revolving. RPM. Angular speed's got to incorporate either radians or degrees, and most likely which one? Radians, because you've been using them anyway for 2 pi r, pi r squared, 4/3 pi r cubed. You've been using them anyway, all right? So I'm going to say the conversion that there are 2 pi radians to 1 revolution. Okay, just like you can say 12 inches in 1 foot. Every revolution, watch my finger. Every revolution, or look up here, every revolution has how many degrees in it? 360. Every revolution has how many radians in it? 2 pi, okay? So you should have gotten your angular velocity as 4,800 pi radians per minute. If you use decimals, that's okay. Just always give me 3 decimal places. But girls, don't round it off to 3 in your calculator. Some of us this morning talked about a composite function. If with the wheels that some girls are going to work for you in a minute, that bicycle problem, you've got an ultra composite function going on there. What do I mean by composite function? F of g of h of x. What's happened? You've got to get the right answer on the big one that leads you to the little one that leads you to the medium-sized one. Okay? So if you miss the big one, what's going to happen to the other 2? All right, so you don't want to round off your answer at the beginning of a problem. Your math teachers have always meant round off your answer at the end of the problem. You have a great calculator, so do y'all know how to use second answer? And it'll just bring that whole long thing down. When you're writing it on your paper, getting you ready for AP Calculus, write it to at least 3 decimal places on your paper, but keep more than that in your calculator. If you round off on the way to an answer, do you see you could fall further and further off the mark? All right? Okay, now, can't lots of tires wheels spin 4,800 pi radians per minute? That doesn't tell me how fast the object's going. That tells me how fast the object is spinning. What's going to tell me how fast the object is going is what the radius is of it, right? Okay? So now, that was the first part of the question. The second part of the question is, I am going to use S equals R theta. This one has a radius of 9 inches. Theta is 4,800 pi radians per minute. And as I was saying at the end of class last time, radians can come in and out of your problem like a ghost. Right now, because they're dimensionless, I hope you realize that. And so now I can just kind of throw them out. I don't really need them right now because this is in inches per minute. And I didn't really tell you what I wanted it in, so I would accept whatever you gave me if I didn't specify. So some of you may have gotten it in inches per minute. But I wanted to go ahead and get it in miles per hour. Did anybody get it in miles per hour? All right, what'd you get?
I got 1,156.
Okay, anybody get a different number? What'd you get?
128.5.
Yeah, so there's something, because both of your numbers have been really close, Kate. There's something that I see in your numbers that's just, oh, I don't think this is it, but remember when you're dividing by 2 pi, which I wouldn't be here. Yeah, but that's not it. We'll find out. So Katie, everybody watch my work. On the test, I probably would say in miles per hour, feet per second, but if I don't say, just leave it in inches per minute. Just leave it there. All right, so now I'm going to say 1 foot has 12 inches. 1 mile has 5,280 feet. I do not keep a running total. I wait and write it all out and type it in my calculator one time. It's a whole lot easier than keeping up with all those ugly decimals. So I don't know if you've been taught that or not. So I now have miles per minute. And so now I'm going to change this minute, 60 minutes, and 1 hour. So now I'm going to say 9 times 4,800 pi times 60 divided by parentheses 12 times 5280. Pick up all the numbers on the top and all the numbers on the bottom, and that should give us 128.520 miles per hour. If at the end you do not have my same 3 decimal places, I will count off at least a point, because we're at a place, girls, where we need to be precise. Most of my students end up engineering, medicine, technology. You got to be precise. Accounting, you can't go almost close. All right, you got to be precise. Katie, what happened?
I just realized I multiplied by 9 twice.
Okay. All right. I thought you were probably on the right track. Bella?
So I know like some teachers when they say 3 decimal places. They
I don't
mean,
mean
like,
3
keep
significant
0.
digits. Oh, go ahead.
They mean like keep the 0 at the end.
Oh, you don't have to. If it rounds to a 0, like when I say 3 significant digits, I'm sorry, I won't say that. When I say 3 decimal places, I'm fine if you just leave that 2.5. What that means is if it goes out further, it's also true most of y'all are still taking standardized tests on the grid ends and SAT, and those of you all of you are probably going to AP Cal. That means if it goes like longer like this, okay, we want 3 decimal places, and we, being AP Calculus and SAT, all College Board, will take truncated or rounded. So what I just wrote on the board, I would accept 62.428 or 62.429. As an Algebra 2 student, I was not a fan of my teacher making me use parentheses and making me write my units down. I thought, I can just do this. Why do I need to do that? Enter pre-cal. You really need your units, and you really need parentheses. Okay, Miss Hosch was 100% right. All the little things I found aggravating, she was right. She just had to wait for us to realize that she was right. Okay, so your units, I think Michaela and Brianna and who else was working in here this morning? Katie would tell you your units a lot of times will save you. They'll guide you to the right answer. So your units are real important. Any other questions before we go to number 3? Lindsay?
Why did you cross out the radians?
Radians are dimensionless. Like if I turn satellite dish 30 degrees, or if I'm in here in this room and we both turn 30 degrees, they don't have a dimension like feet or inches. Radians and degrees are dimensionless. Aren't there lots of things that can turn 360 degrees, but you have no idea what size they are? It's a turn. They don't have a dimension. Okay? So they can come in and out of the problem as you need them. They're not affecting your dimensions. They aren't messing them up. But if I've all of a sudden gotten a theta, I need to write down radians so I see what I've got. Okay? S equals r theta. All of your area, everything you've ever done with something that's circular was in radians. Do y'all realize that? pi r squared, 2 pi r, 4/3 pi r cubed. Everything somebody's handed you was in radians. Kind of weird to think about. So as you're using S equals r theta, that formula only works if you put in radians. But if you get theta out of it, if you set S and R and you're looking for theta, guess what it's in? If you're using that formula, it's coming out in radians, okay? And so if you need to put that word in, you can to kind of get your bearings. You can also lose it, all right? So if I have something, Lindsay, just to reiterate, if I have something 4 inches, it's spinning 180 degrees per minute. And if I have something that's 8 inches, spinning 180 degrees per minute. Once I find the arc length, I don't need those degrees anymore. I just need to know how far it went, okay? All right, now let's do number 3, even though we've sort of done number 3. All right, number 3 is like this that I talked about. So there's this like pulley kind of hoist system that we're trying to pull an object up 2 feet. If this goes up 2 feet, that means it would have had to wrap around there 2 feet. That's the same distance. Does everybody see that has to happen as it travels? So I'll grab S as my distance. So I'm going to say 2 feet equals R. The diameter is 3 feet, so the radius was 1.5 feet. This is going to go right back into Lindsay's question. Watch this. Okay? If I divide by 1.5 feet, a lot of y'all did this and got 1.3 repeating or 4/3. It's real important not to use 1.3. You better use, if you're using decimals, use lots of 3s, okay? I'm going to call this 4/3 equals theta. Girls, my feet just completely canceled out. It looks like I don't have a dimension. That's because theta's in what? Radians. It's a spinning action. It's spinning, okay? It just turned 4.4 of a radian. However, 4/3 of a radian, girls, here's a radian. Remember, I take the radius and start to wrap it around the circle. Remember that illustration that I gave you? Say yes, I remember that, okay? So 1 radian is about this big, okay? It's about 60 degrees, actually. It's more like that big. If you think of 1 1/3 radians, let's see what happens to our answer. How do I change 4/3 of a radian into degrees? You multiply by 180 degrees over pi radians. And you should have gotten 76.394 degrees. All right, look at my picture. Girls, let's listen to me. Do you see how 1 1/3 radians makes sense to be about a turn of 76 degrees? Also, in this bad picture that I drew, that makes sense to me. To pull it up, I would turn about 76 degrees, okay? So I want you to just be well versed in radians and degrees. Isabella?
This is how you got the.
It said that the size of the hoist is 3 feet. Do you see that? Okay. Nicole?
I know this is like not right, but like it kind of made sense to me. I did like X degrees over like 2 feet, so like that's how far it goes in like 2 feet. It's like for it to go like 90 degrees, it'd go 0.75 pi feet. And then
Did you get the right answer?
No.
Okay, well, can we just now do
Yeah.
this? Okay. But so we can talk about like maybe why that went wrong later, but this will always work. Let's just use S equals R theta, S equals R theta. S is the distance you want to pull this up, and you have a radius and an angle. So hopefully you were listening to me work it instead of thinking about what you did.
I wrote this down.
Okay. I would be glad to meet with you, and the class is so big that if we talk about what you did, it might confuse them. But Katie's doing something different that's working for her. It's not really different. It's just how her mind is thinking through it. And it would be hard maybe for her to explain it to me. But she's getting the right answer, so I'm not going to mess with it. Okay? But that's why I said, are you getting the right answer? Then I was going to go, well, then if you're getting the right answer every time, well, it's just whatever your brain is thinking, you're still doing the same thing we're doing. But apparently you're doing something different. But come by and we'll talk about it, okay? I feel like I've got the class moving with me now, so I don't want to like stop and rehash all that. All right, now, girls, my fault. I've made a lot of mistakes this week. I hope this, It doesn't really make any sense for me to have something going to number 4. Oh, I'm sorry, I'll go back and finish number 3. Then I'll go to number 4. All right, number 3. It was an interesting question. On number 3, there was a second question. Find the distance. What are you looking for? Find the distance, the S. We know the radius is 1.5 feet. And I gave you theta. What if you turn it 7 pi over 4 radians? That's 315 degrees. You're going to take this and you're going to turn this 7 pi over 4 radians. This object's going to go a lot higher, isn't it? Okay? So why don't you really have to do anything to this problem? Because it's already in what? If I said turn it 120 or 315 degrees, you couldn't use the formula until you convert it into radians. Okay? Again, which is not new. 2 pi r squared. All right? Back to Lindsay's question. Why is there nothing next to 7 pi over 4? I could put it in, but it would just be radians. Okay? If you did this right, you should get 8.247 feet. All right? Okay. That's a 7. Rebecca?
When you're writing your answer and it's like in radians, do you have to write radians next to it on the test, or can you just sort of-
No, if there's no circle there, I'll know you're in radians. Okay? Yes. Okay, girls, hopefully, well, you didn't know enough about bicycles and all this stuff that we're talking about, so I was bonus, and I just kept telling people, just try. Just happened to have a few people in here in the Math Center trying. Well, I kept saying, I'm not going to help you, I'm not going to help you, I'm not going to help you, okay? But it makes absolutely no sense for me to try to use a machine to make myself fat. Now, there's machines that have belts like this, like conveyor belts, like at the airport, okay? And so it does make sense sometimes to have these the same size if I'm just going to stand here and be pulled along, all right? But if I want to make myself more efficient, one needs to be bigger than the other one, okay? So, hang on, Rebecca. Sorry.
Is it bigger because of the diameter of the wheel?
Yeah, but then you can just have it go on because it's moving like.
Well, what's happening is this one really should have been 5.
So the point is that by having the 2 separate gears, you can go faster than you would in the
So that
How would you sit with the pedal underneath it?
it's not underneath.
A unicycle.
I know, but like,
A unicycle has the same thing.
Wait, so the pedal diameter has to be bigger so that you don't have to rotate as many times to the same distance.
I drew, hey girls, listen. Listen.
Yes.
I drew a picture for you at the bottom. I didn't draw that before, so I drew that. Okay. I'll put it into the thing. If you look at all of these bicycles, look at the pedal sprocket and look at the wheel sprocket. Do you see how much bigger the pedal sprocket is than the wheel sprocket? So if I just go, oh, I'm just going to ride a little bit. That one's having to spin really fast, right, Pietro?
Yeah.
Okay. So please don't buy a bike where the pedal sprocket and the wheel sprocket are the same size. So you have to go through a whole lot more effort. The reason they made this simple machine is because this really should have been bigger. I just made up both 2 accidentally. That's why I was taking both answers, okay? This one really, if everybody would change the word pedal sprocket to 5. We're about to work it with 5. The pedal sprocket's 5 inches. The wheel sprocket is 2 inches. And did y'all pick up on the tire was 14 inches in radius?
Yeah.
Okay? Girls, the reason I said it that way is that's usually how things are reported to you. If you're looking something up about to buy a bike or a car, a lot of times they give you the diameter and you need to calculate the radius. Okay? This is wheel sprocket, sorry, this is pedal sprocket. This is your legs doing this. And you're not even looking at the back. You're just riding along in Central Park. Meanwhile, this little guy's spinning like crazy and it's bolted to the big one, which is having to spin like crazy. And this arc length is being laid down on the ground. All right, now Rebecca, I kind of cut you off. Was there anything else you wanted to say?
No, just about the
Okay, so all right, Elaine?
So the arc length, like when you spin like the pedal, is the same as the arc length on the tiny one, so then it has to spin faster on the tiny one.
Yes, yes. Because that's why they put it with a chain. if I chain us together, I'm gonna have to go as fast as you.
Right.
I'm not spinning as fast as you, I'm gonna have to spin faster than you, cause I gotta keep up.
Okay.
So if you chain those together, those have the same S, which I will, detail for you right now, and then Michaela and Brianna are gonna work the problem for you. All right, so, okay. So, and girls, let's stay quiet. I've had to get you quiet some today, and I need to keep moving because there's a couple more things we got to get done after this. Okay? By the way, I would not give you any problem that's more difficult than this, and nor would there be any need to, because if you get this problem, you get the whole concept. Okay? Here's a bicycle that I'm not going to attempt to draw. This is just the interaction between the pedal sprocket. Here's a little pedal. All right, this was supposed to be 5. A lot of times this is 2. And this bike that I gave you was 14. I looked up kind of typical dimensions. Obviously, we're not getting in depth as people that make bicycles because they also have to figure out what if you change gears. It makes a bigger or smaller radius in the back. Girls, shh. Okay. These have the same S. Let's call this wheel 1, wheel 2, and wheel 3. Okay? As Elena said, wheel 1 and wheel 2 have the same S. Wheel 1 and wheel 2, do they have the same radius? No, okay? If they don't have the same radius, the only thing they can have the same of is one thing. They can have the same angular velocity or linear velocity, okay? Those have the same S. What do wheel 2 and wheel 3 have? Oh, wait, did I label these very well? This is wheel 1, this is wheel 2, and this is wheel 3, okay? What do wheel 2 and wheel 3 have if they're bolted together? They have the same theta. It's like what I told some girls today. If we're on the carousel together, and I'm on this horse, and you're on that horse, and your friend's on that horse. When this carousel turns, won't we have the same theta? I'm bolted. That horse is bolted to the ground, okay? So if the carousel starts to turn 60 degrees, my horse will turn 60 degrees. So will your horse. So will your friend's horse. If you notice, they don't have the same S. All right, so this is key. All right, so Brianna and Michaela are going to show you how they did it.
No, thank you.
Oh, you changed your mind? Oh,
No, come up with this.
you did it.
Good.
I just sat there working.
Yeah, but we don't.
Do you want me to? Do you feel like you can't explain it?
We don't want to like confuse people.
Okay, I'll do
There are a lot
it.
of
Please,
things going on.
please put your input in. But they were just brainstorming together, and I turned around. I'm like, that 3017 number was on the board. I'm like, y'all are on the right track. Then I realized that they didn't get the right answer because I had given them the wrong radius.
Let's see.
This, it's right here. It's right here. Okay, but we're about to write it up. All right. Okay, so you're going to start. You're going to get on the bike, and what are you going to do? What's going to be impacted first is your pedal sprocket, right? If you get a city bike, you pull it out, and then you get on it, and you start pedaling, or it's not going to move. All right. So I'm going to go to the pedal sprocket. This chain to the wheel sprocket. They're chained together. All right. This radius, I'm sorry, was supposed to be 5, and this radius was 2. Let's start pedaling. All right. S. Okay, I've said about 4 times I made a mistake, but I also gave credit for the people that worked it with the 2. Okay? All right. I'm working it with the 5. Lily and Danielle. You have to be able to do this. All right? As I start to pedal and this thing starts to go, it goes through a certain amount of chain. This one has to go through the same amount of chain as I pull it. Okay? So S, I'm sorry, I shouldn't start with that. I stand corrected. It kind of depends on what I ask you. This one, which S were you given? It told you that the bike was going 40 miles an hour. And so you want to know, how fast you've got to pedal to make your bike go 40 miles an hour. Which one of those things is really going 40 miles an hour? Is wheel 1, wheel 2, or wheel 3? Wheel 3, good. That's its S. Isn't it starting to roll along the ground like this? Okay, so I'm going to say S equals R theta. I'm about to make your life a lot easier too. You're going to be shocked that I'm not going to change miles and inches into each other. But just be patient, okay? So I'm going to find theta. I'm going to find out how my angular velocity of this big wheel, okay? So I'm going to say 40 miles per hour times 1 over 14 inches equals theta. Did y'all see how I just divided by 14 inches? I wouldn't even get that number, plus you can't right now. You have no business dividing miles by inches anyway, right? I didn't say a word, but I think that everybody in here this morning changed miles to inches. I'm not going to, and you'll see why, just because I've worked the problem so many times, okay? And you can do this also. Because I'm not even going to get that number yet. Whatever that number is, I'm just going to leave it as is right now. Now I'm going to go to wheel 2, because these are bolted together. The blue wheel and the red wheel have the same what? If I bolt two things together and spin them, they've got to have the same what? They've got to have the same theta. Girls, if I bolt things together, they have to turn together. They have no choice. Wheel 2 and wheel 3 have the same theta, okay? So now I'm going to go to wheel 2. I just left wheel 3. Wheel 3 was 40 miles an hour with a 14-inch radius. Now I'm going to wheel 2. Wheel 2, now I know my theta of wheel 2 because I bolted them together. I'm going into S equals R theta with wheel 2. Wheel 2, the little bitty pedal sprocket, is 2 inches. I know theta is 40 miles per hour times 1 over 14 inches. And it's only because I've worked this problem before, and also I'm just like tutor so much for standardized tests that you learn all these great tricks. Do you see that I could have changed it all to miles or inches, but they're about to cancel out anyway, so I kind of just didn't need to do it. Sorry. I told you I wasn't going to help you. All right, so now you can like start multiplying or just keep up with these numbers. That's just sort of up to you, okay? I tend to lose things. I know that that's 80 over 14, or I could reduce the 2 into the 14 and make it 7. You make your own decisions. I'm going to keep all the numbers just because I lose things, okay? Now, what has the same S? Elena's already said it. Once this is going around, these are chained together, so they've got to have the same, look, linear velocity. They've got to have the same S. So now I'm going to the pedal sprocket. S equals R theta, okay?
Wouldn't S just be that?
It's this number, 2 times 40 miles per hour.
And
Um,
right now we're trying to find.
It's kind of aggravating to keep all those right now, but I'm just going to. 1 over 14 equals 5 inches times theta. I'm just going to go in and call this 80. So I have 80 miles per hour times 1 over 14 times 1 over 5 inches equals theta. Now I can't avoid it. I've got miles and inches and I'm at the end. Notice in wheel 1, I knew S and R. I found theta. I'm sorry, that was what I was calling wheel 3. Excuse me. In wheel 3, I knew it was going 40 miles an hour and I knew its radius. I found theta. That led me to wheel 2, where I knew the radius and theta took me to its S. Now I'm going to wheel 1. I'm on wheel 1, where I know the radius and I know S, so I just found theta. So now I'm going to say 80 miles per hour times 1 over 14 times 1 over 5 inches. I'm going to say 12 inches in 1 foot. I'm going to say 5,280 feet in 1 mile. I do have to do it at least once. Oh my goodness, I don't have any words on the top. Okay? That's because what is theta coming at me in? Radians. And so like I've told you, it can come in and out of your problem as you need to. However, I'm eventually going to want it in revolutions per what? Minute. So I'm going to say 1 hour has 60 minutes. And then this is in radians. So my final step is I've got to change it to RPM, which always means revolutions. So I'm going to say 1 revolution has what? 2 pi radians. And so I'm going to say 80 times 12 times 5280 divided by 14 times 60 times 2 pi. I think that's all the numbers. A couple of y'all try that. I hope we get 192.077. There's a 5 somewhere. Oh, here's a 5. Thanks. There's a 5 in there. All right. Do you get 192.077?
I got that, but I didn't use like S equals R.
Some people can think logically through it. I'm not going to mess with that. You have to be, but you just are doing it so logically you don't feel it. If you had to do this a lot or to program something to make this happen, where if you wanted often, like constantly just to go, I'm going to go 30 miles an hour, how fast do I have to go? You would have to use S equals R theta to program. But if you got that right, I'm not going to mess with your brain, okay? I thought you must have been doing something right, okay? Girls, let me tell you about your homework as you're leaving. Your homework, I will post another bicycle problem, okay, that is part of your homework. As far as you know right now, it's not bonus, okay? I think we're going to talk about it a lot more, so it's probably not bonus, but you want to be able to do it to see if you can do it on a test, okay? Also, you're going to have this worksheet. And you get to go home and integrate, do it in degrees. I'll put this on the assignment page. This will take you 12 seconds, okay? Keep listening because we got to go. Listen. All of a sudden, I'm going to give you the ratio and we're looking for the angle. That's when you push inverse sine, inverse cosine, inverse tangent, okay? Yeah, because I just want you what to do. If you think you can do it without your calculator, that's fine. You'll only get one answer on your calculator. Please only write that one answer down and we'll talk about it. See if we all get the same one. I don't have a marker, so I can't show here. Sometimes I get really aggravated with typing this into my document. So there's another notation for it. I can also call it arc sine or arc cosine. I wrote that at the top of the word. So if you're in degrees, this will take you 15 seconds. But eventually we got to be able to do this without our calculator. Intro to inverse trig functions. So I'll be at the door. Pick one up. And also you'll have a bicycle problem. I'll post that.
I'll be here for the what?
Awesome.